Now imagine what happens as the car moves. As the car moves, the wheels go over, right? The wheels go over the step, and as I said, you're going to feel a bump, right? A sudden jump in the car, and that's not always very nice, right? Especially if it's a big step, or if it happens a lot, right? You'll just keep feeling this up and down motion, which can be quite uncomfortable. Now that's the purpose of these little springs here. They're supposed to absorb the shock. So hopefully when the car drives over the little steps or bumps, the bumps would cause the wheel to move up suddenly, but hopefully this upward motion will be somehow taken up by the spring. Okay, and my guess is that probably all cars would have such a system. Now this system, meaning this arrangement with the spring in between the wheels and the car's body. Okay, this system has a name. It is called let's write it down here. It is called a car suspension system. I suppose suspend as in the car is suspended by some spring above the wheel. And the purpose of this is quite simple, is to absorb the shock, is to somehow let this sudden movement from the bump get taken up by the spring, right? So that instead of jerking the whole car up when the wheel goes over the step, the wheel will jerk up, but the spring compresses so that the car's body does not also jerk up, or at least it doesn't jerk up so immediately, so suddenly. So that's a car suspension system, to absorb the shock from the bumps on the road. Now, but as we know, if you have ever sat in a car before, it is not perfect, and when the car goes over a bumpy road, it can still be quite bumpy. And if it is an old car with a worn out or poor suspension system, it's going to be very bumpy anyway. Okay. So what I like to do now is to look at how this suspension, this spring here works, and how it could be adjusted to give so that it can absorb the shock better. And this has something to do with the ideas of underdamping, overdamping, and critical damping that I described in the last session. Okay, so let's try that. Now if I imagine that let's see, let me just think about this level where the spring is in contact with the car's body. So it is this level here, and let me think about this level where the axle is. Okay, now what's going to happen when the wheel just moves over the bump? Now we can imagine that the car is driving quite quickly. And the mass of the car's body is quite big. There'll probably be a few people, maybe up to four or more people sitting in the car. So it's going to be hundreds of kilograms that we are talking about. Okay, so then when the wheel moves over the step, because the car is driving quite fast, the step would give a very sudden push on the wheel. So very suddenly, this wheel axle would be moved up. So it would compress the spring very suddenly. Okay, and this happens maybe in the first fraction of a second. And then at that moment though, the car's body, because partly because it's so massive, partly because the time is so short, it would not have moved yet. So it would just be the axle that has moved. So that means that this level, this yellow, this green line here, the level of this part of the car's body, it would at first stay about the same, at least in the first fraction of a second. Whereas this yellow level, okay, it would suddenly move up. Right? So it would suddenly move up. So in the first fraction of a second, the axle of the wheel would suddenly have moved up, and the spring would become compressed. So the spring will become compressed to a shorter length. So it become compressed to a shorter length. Now after that, the wheel axle would then continue along here at the same level. All right, because the axle must always be at the same distance from the ground, since the size of the wheel is fixed. Okay, so thereafter, we would expect the axle to continue at the same level. Whereas, because the spring is compressed, it would exert a force. It would exert a force, all right, both downward and upward, but it can't push the axle down anymore since the distance is fixed. So it would push the car's body up, okay, back to so that the spring would want to extend back to its original length, because right now it is compressed when you just go over the step. So it would move the car's body up to its original length. All right, the spring would spring back up. Now you know what springs do. As the spring wants to spring back up, it will spring back up, okay, but it will also oscillate. So it's like when you compress the spring and let go, it will start oscillating. So that's what we would expect to happen. And you'll feel, if you're in a car with a spring that behaves like this, after it goes through a step, you'll feel the car body moving up and down. Okay, and if it does that all the time, you might feel pretty car sick after some time if you're not used to it. Okay, now let me expand this part of the drawing. I'm just going to keep the step size about the same, and now, so this is my wheel axle, which has moved up here. I'm just going to leave out the wheel, or maybe just draw a dotted shape to represent the wheel, and we have the car's body in which was at this level at first. Okay, that's my car, and my little spring, which has been compressed because of the sudden upward motion of the wheel axle as the wheel goes over the step. Okay, so let's see. So what happens as I try to describe it up there is that the car's body, and this if I follow this level of the car's body, the compressed spring would want to extend back out. Alright, so it would have a force that pushes up the car's body. Now, as with all oscillations, it would overshoot what would be the rest position, and then the car would go a bit higher than its rest position, the car's body, and then it will come back down again. It would oscillate a bit, maybe before it stops oscillating because of the whatever air resistance or other resistance that is present. So we would expect this to happen. It will go up, down, up, down, up, down. Okay, so the oscillation would happen about maybe some certain rest position, where hopefully after some oscillation, the oscillation would become smaller and smaller, and the car would stop oscillating and stay at this level. So after that, we can relax. Okay. Now, and as I've suggested, if it happens once, it's tolerable. But if the road is going to be bumpy, and you're going to get hundreds of bumps after that and steps after this first one, then the car is just going to keep oscillating every time it goes over a bump, and that's not very nice at all. So instead, we would like the car to quickly come back to a rest position. Instead of oscillating for some time after each bump. Now, as I've described the last session for underdamping and critical damping and overdamping, we've already seen that in order for the car to come back most quickly, come back in the shortest time to the rest position, the spring and this whole oscillation must be critically damped. In other words, as it is, when you see so many oscillations, it is a situation of underdamping. That means that there is not enough damping, or not much damping, not much resistance, which is why the car can go up and down for some time. Now, but if it is possible to add more damping, add more of this resistance to the spring or to the motion of the car, then it would be possible for the it should be possible to adjust this resistance so that the car's body reach this final level in the shortest possible time without doing any oscillation. And that's the situation for critical damping. Okay, so if we want critical damping, then we want the car's body to quickly approach the rest position, right, from this level to this final rest position. So if you can do that, that would be critical damping, and that means that when people design this car, they have to design the suspension system. That means they must use suitable materials to somehow increase and adjust the damping to the spring, okay, so that it would be critically damped, so that there's just enough damping for the car to return to its rest position in the shortest possible time. And I don't really know what is the usual method of doing that in the car. It might be possibly be I don't know, maybe some electrical system that induces current and heats up and takes away the energy, or there might be some oil. It might be some parts of this might be immersed in oil, which increases resistance. There could be many designs that people have come up with. Now, the other extreme case would be when there is too much damping. When there's too much damping, the car would take a long time before going back to this rest position. So that means that maybe instead of coming back to its rest position, it would just stay. The spring might just stay roughly at this compressed position, all right, or it would just extend very slowly. So you stay around that compressed level for quite a number of seconds, maybe, or minutes, before the car, the body slowly moves up to its rest position. Now, this slow, if you like, slow recovery, right, the slow getting back to the normal position, it would be a problem as well, because if the spring stays at the compressed position, then when the car hits the next bump, okay, because if the spring is already compressed, then it won't be able to take the shock. It may not be able to compress very much more when the wheel goes over the next bump. And if it can't compress anymore, the whole car body would jerk upwards if there is another step further down the road.